Computer network. Computer network is an interconnection of multiple devices, also known as hosts, that are connected using multiple paths to send or receive data or media. Computer networks can also include multiple devices or mediums which help in the communication between two different devices. These are known as network devices and include things such as routers, switches, hubs. Ethernet hub connects broadcast signals to computers within a local area network, LAN, through a process called frame flooding, also known as unicast. It is like one big blast. A hub does not differentiate between MAC addresses, and indeed cannot. It does not have the software required to identify specific targets. A hub is essentially an unintelligent device. Each incoming bit is replicated on all other interfaces. A hub is an easiest and least expensive way to construct a network of personal computers together. MAC stands for Media Access Control. It's either a 48-bit or 64-bit address given to a network adapter at the time of a computer's manufacture. A MAC address is the hardware address for that device. An IP address, on the other hand, is a software address. Both of these can be found in that particular computer's network interface card (NIC). These addresses allow both hubs and switches to transmit data to a computer. A switch is an intelligent device, transmitting to specific MAC addresses within the LAN. It can learn or remember and distinguish between specific addresses by accessing them from a CAM table. The software allows the switch to regulate traffic, eliminating spammy signals and making connected networks highly efficient. A switch costs more, but it not only supports personal computers but also supports a variety of other IP devices. That brings it into the realm of the Internet Things and the ability to support remote devices within a larger WAN, VLAN, or LAN. Intelligent features allow administrators to turn ports off and on, or filter, through specific ports and manage VLAN security. A network switch generally has 24 to 48 ports. A router is a device that connects two or more packet-switched networks or subnetworks. It serves two primary functions: managing traffic between these networks by forwarding data packets to their intended IP addresses and allowing multiple devices to use the same internet connection. There are several types of routers, but most routers pass data between LANs, local area networks, and WANs, wide area networks. A LAN is a group of connected devices restricted to a specific geographic area. A LAN usually requires a single router. LAN or local area network connects network devices in such a way that personal computers and workstations can share data, tools, and programs. The group of computers and devices are connected together by a switch or stack of switches, using a private addressing scheme as defined by the TCP/IP protocol. Private addresses are unique in relation to other computers on the local network. Routers are found at the boundary of a LAN, connecting them to the larger WAN. VLAN is a collection of devices or network nodes that communicate with one another as if they made up a single LAN, when in reality they exist in one or several LAN segments. In a technical sense, a segment is separated from the rest of the LAN by a bridge, router, or switch, and is typically used for a particular department. This means that when a workstation broadcasts packets, they reach all other workstations on the VLAN but none outside it. Metropolitan area network covers a larger area and that of a LAN and smaller area as compared to WAN. It connects two or more computers that are apart but reside in the same or different cities. It covers a large geographical area and may serve as an ISP, Internet Service Provider. MAN is designed for customers who need high-speed connectivity. Speeds of MAN range in terms of Mbps. It's hard to design and maintain a metropolitan area network. Wide area network is a computer network that extends over a large geographical area, although it might be confined within the bounds of a state or county. A WAN could be a connection of LAN connecting to other LANs via telephone lines and radio waves and may be limited to an enterprise, a corporation or an organization, or accessible to the public. The technology is high-speed and relatively expensive. OSI model. To minimize proprietary solutions, to create an open market in network systems, and to enable management of communications complexity, the International Organization for Standardization, ISO, has developed a reference model for open communications. This reference model, called the ISO Open Systems Interconnection, OSI, reference model, proposes an abstract and layered model of networking. Specifically, it defines 7 layers of abstraction and the functionality of each layer. However, it does not define specific protocols that must be used at every layer but gives the concepts of service and protocol that correspond to each layer. Physical layer. These protocols employ methods for bit transmission over physical media and include such typical functions as signal processing, timing, and encoding. Data link control layer. Its protocols establish point-to-point communication over a physical or logical link, performing such functions as an organization of bits in data units, frames, organization, error detection, and flow control. Network layer. These protocols deliver data units over a network composed of the links established through the DLC protocols of Layer 2. Part of these protocols is the identification of the route the data units will follow to reach their target. Transport layer. Transport protocols establish end-to-end communication between end systems over the network defined by a Layer 3 protocol. Often, transport layer protocols provide reliability, which refers to complete and correct data transfer between end systems. Reliability can be achieved through mechanisms for end-to-end error detection, retransmissions, and flow control. Session layer. This layer enables and manages sessions for complete data exchange between end nodes. Sessions may consist of multiple transport layer connections. Presentation layer. This layer is responsible for the presentation of exchanged data in formats that can be consumed by the application layer. Application layer. The application layer includes protocols that implement or facilitate end-to-end distributed applications over the network. IP is a routable protocol, meaning it can be sent across networks, that handles addressing, routing, and the process of putting data into or taking data out of packets. IP is considered to be connectionless because it does not establish a session with a remote computer before sending data. Data sent via connectionless methods are called datagrams. An IP packet can be lost, delayed, duplicated, or delivered out of sequence, and there is no attempt to recover from these errors. Recovery is the responsibility of higher layer protocols, including transport layer protocols such as TCP. Transmission Control Protocol. IP is a connectionless protocol, which means that each unit of data is individually addressed and routed from the source device to the target device, and the target does not send an acknowledgement back to the source. That's where protocols such as the Transmission Control Protocol, TCP, come in. TCP is used in conjunction with IP to maintain a connection between the sender and the target and to ensure packet order. For example, when an email is sent over TCP, a connection is established and a three-way handshake is made. First, the source sends an SYN, initial request packet, to the target server to start the dialogue. Then the target server sends an SYN-ACK packet to agree to the process. Lastly, the source sends an ACK packet to the target to confirm the process, after which the message contents can be sent. The email message is ultimately broken down into packets before each packet is sent out into the internet, where it traverses a series of gateways before arriving at the target device where the group of packets is reassembled by TCP into the original contents of the email. The Domain Name System, DNS. The Domain Name System, DNS, is a system for computers and services connected to the Internet that resolves domain names to IP addresses. It converts human-readable domain names, like www.google.com, into Internet Protocol, IP, addresses. Computers can only communicate using a series of numbers, so DNS was developed as a sort of phone book that translates the domain you enter in your browser into a computer-readable IP. Ethernet is a network protocol that controls how data is transmitted over a LAN and is referred to as the IEEE 802.3 protocol. Ethernet is the most popular physical layer LAN technology in use today. It defines the number of conductors that are required for a connection, the performance thresholds that can be expected, and provides the framework for data transmission. A standard Ethernet network can transmit data at a rate of up to 10 megabits per second. User Datagram Protocol, UDP. Like IP, UDP is a connectionless and unreliable protocol. It doesn't require making a connection with the host to exchange data. Since UDP is an unreliable protocol, there is no mechanism for ensuring that data sent is received. File Transfer Protocol, FTP. FTP is used to copy files from one host to another. FTP offers the mechanism for the same in the following manner. FTP creates two processes such as control process and data transfer process at both ends, i.e. at the client as well as a server. FTP establishes two different connections, one is for data transfer and the other is for control information. Hypertext Transfer Protocol, HTTP. HTTP is a communication protocol. It defines a mechanism for communication between the browser and the web server. It is also called Request and Response Protocol because the communication between browser and server takes place in request and response pairs. Secure Sockets Layer Protocol. SSL stands for Secure Sockets Layer and, in short, it's the standard technology for keeping an internet connection secure and safeguarding any sensitive data that is being sent between two systems, preventing criminals from reading and modifying any information transferred, including potential personal details. It does this by making sure that any data transferred between users and sites, or between two systems, remain impossible to read. It uses encryption algorithms to scramble data in transit, preventing hackers from reading it as it is sent over the connection. Secure Shell Protocol. Secure Shell is a method for securing remote login from one computer to another. It provides several alternative options for strong authentication, and it protects the communication security and integrity with strong encryption. It is a secure alternative to the non-protected login protocols, such as Telnet, Relogen, and insecure file transfer methods, such as FTP. The Internet Control Message Protocol, ICMP. The Internet Control Message Protocol, ICMP, is a protocol that devices within a network use to communicate problems with data transmission. Traceroute and ping use ICMP. Traceroute and ping are messages sent regarding whether data was successfully transmitted. When traceroute is used, the devices that a packet of data went through to get to its destination are displayed in the report. ICMP facilitates ping in that the ICMP echo request and echo reply are used during the ping process. Simple Mail Transfer Protocol. SMTP, which stands for Simple Mail Transfer Protocol, is an email protocol used for sending email messages from one email account to another via the Internet. Email protocols are sets of rules that let different email clients and accounts easily exchange information, and SMTP is one of the most common ones alongside POP and IMAP. It is also the only dedicated protocol for sending emails. Devices in a local area network are programmed to communicate using link layer addresses. Switches are not configured for a standard that will allow destination decisions to be based on IP within the same broadcast domain. A device that is not connected to the Internet will not have an IP address. In that case, the network has to resort to using MAC addresses for communication. If a device wants to communicate with another device in the same LAN, it needs to know the MAC address of the other device's network interface. This allows for the communication between the two end devices to be unicast. ARP is a request-response or request-reply protocol in which one device sends a request to another device asking for some information, to which the other device will reply with the required information. It is a message exchange pattern. Dynamic Host Configuration Protocol. DHCP stands for Dynamic Host Configuration Protocol and is a network protocol used on IP networks where a DHCP server automatically assigns an IP address and other information to each host on the network so they can communicate efficiently with other endpoints. In addition to the IP address, DHCP also assigns the subnet mask, default gateway address, the domain name server, DNS, address, and other pertinent configuration parameters. DHCP server, a network device running the DCHP service that holds IP addresses and related configuration information. This is most typically a server or a home router but could be anything that acts as a host, such as an SD-WAN appliance. Most probably every computer user saw this IP config table. When you select to obtain an IP address, automatically your home router will assign your computer an IP address, gateway, and DNS.